Alright, we're back again. So this time we're looking at a rough incline example. So rough incline planes and tension even applied. So without further ado, let's jump in. So suppose we have a box of mass of 8 kg that rests on a rough plane. Okay, so keyword rough meaning we're going to include some sort of coefficient of friction, mu, which is inclined at 30 degrees to the horizontal. The box is kept at equilibrium by a light string. So it's light, so we assume that there is no mass in the string. Okay, let's just jump straight to that point, which makes an angle of 15 degrees with the line of the greatest slope of the inclined plane. So this phrase, the line of the greatest slope, this just means when you're inclined, you're making 15 degrees on the incline. So yeah, we'll see that once we draw it. And the last point, when the tension T in the string is 15 newtons, the box is in limiting equilibrium and is about to move out the plane. So hence, just about at this point in time is where the equation will equal 0 once T is 15. So, and the task is to find the coefficient of friction between the box and the plane. Okay, so I know you want to draw here, but let me draw it on a fresh page because this will take one page answer. So let's jump in. So let's draw the mass, the box of mass at 8 kg at rest on the plane. So we have something that looks like this. Okay, so we have to be very accurate here. Yeah? So we know this is inclined at 30 degrees. Okay, and we know this weighs what? 8 kilograms, so 8g. And we know there's always a normal reaction perpendicular. We call this R. They told us that there's a tension T that is angled at 15 degrees. So this is what it means. So this is where the rope is angled. It's angled here at 15. So we're going to remember this part is equivalent to this angle here using some alternate angle property from GCSE. And this one here is 15 degrees. Of course, imagine that there's a y-axis here too. So this is the y-axis. That means we know that this part is perpendicular. So 30 plus 15, the remainder part must be 45 to make 90 degrees. Okay, so there's a 4. Now let's fill out the rest of the angles here. So, oh it is. So this should be the tension T, by the way. So tension is over here. We call this one T. On this side, again, drawing extending axis across to match the line. Because these are alternate angles, this also is 30 degrees. And this is perpendicular to plane, so this must be 60 degrees. Again, and this makes 90, so this one is also 30 degrees. And that's it, guys. Now we just resolve. So let us resolve. Oh yeah, don't forget the side. 60 degrees. So resolving vertically, we have this. What do we have? So we look at the first one, R. So R, we have R cos 30 plus T cos 45. And what else do we know? We also know that there's so there's also a frictional force. So yeah, there should be a friction force over here. Because it's a rough plane, we always apply friction. So here's F, so this would be minus F cos 60 minus 8g. Okay, nice and straightforward. And again, so this is always the hardest bit, it's always to label it. So remember, the friction always applies because it's a rough plane. And it's always in the opposing direction to where it's being pushed or whatever. So moving to the right, we're pulling it up the plane because of the rope. Hence there's some friction dragging on the left on this opposing direction. Now, opposing to the right, we're going to have T cos, and this is to the angle of 15 plus 30, so T cos 45. Remember, we sum up the 15 and 30. Nothing else. On the left hand side, we've got R cos 60, so negative R cos 60. And we also have minus F cos 30 equals 0. Okay, good. Now it's time to start resolving. Okay, so here comes the more interesting math. So we just have to be very good with our mathematical technique. There's going to be a hell lot of substitution involved. So let's jump in. So recall that according to the question, we know that the tension T in the string is 15 then the box in limiting equilibrium about to move up the plane. So again, hence why the friction is that way. So let's say when t equals 15, we can somehow simplify all of this craziness. T equals 15 newtons, and we're trying to find the coefficient of friction. We know that F equals mu r. Hence we can simplify a lot of this. Therefore, using the up arrow equation, we can get, putting this in the calculator, root cos 30, so we're going to have root 3 over 2 r plus t cos 45 simplifies to 15 over 2 root 2 minus cos 60 is half, f is mu r, so it'll be half mu r minus 8g equals 0. And factorizing r and then plus minusing these two components, ag minus 15 root 2, factorizing r and dividing it, we should get r equals, so this is a quick step, plus ag minus 15 over 2 root 2 all over, and we factorize these two components with r's, we're going to get root 3 over 2 minus half mu. So this will be what's inside. And to really sort this top line out, this gives us about 67.8 over root 3 over 2 minus half mu. Okay, now we're going to sub all of this into the second equation. Okay, and we have to simplify this law again. Okay, so substituting this entire equation into the horizontal one, and remembering to replace f with mu r and then factorizing this completely. So let's just break it down. We should get, so the right hand side, t cos 45 with t is 15 reduces to 15 over 2 root 2 minus factorizing f on both sides, we're factorizing r, and then breaking down, we're going to have cos 60, which is half, plus root 3 over 2, because that's cos 30, equals 0. Now this looks much better, doesn't it? Therefore, 15 over 2 root 2 minus r, so here comes a crazy one. We're going to get, boy, we're going to get a really big one, aren't we? We're going to get 67.8 over root 3 over 2 minus half mu, bracket half, so all of this put bracket 2, half plus root 3 over 2 equals 0. Multiplying everything by root 3, all of this, blah blah, root 3 over 2 minus half mu on every component, we should get 15 over 2 root 2 root 3 over 2 minus half mu. This cancels out, minus 67.8 times half plus root 3 over 2. So there's a mu missing somewhere. Yep, there's a mu here. F, is it the F? Mu equals 0, because this comes from the F. Yep. And therefore, guys, this is just a simple equation. Once you expand this and make mu the subject, you should get to a result of mu roughly equals 2. You won't believe it, negative 0.39. And yes, the coefficient of friction is negative, and that is possible. And yeah, most time you'll probably get positive one in your M1 papers, but I just want to clarify that negative is possible. And what does this imply? This means that if the coefficient of friction is negative, then it would increase the total lateral force. In other words, there would be nothing to prevent motion. So it will be tipped, the slide. And yeah, that's it, guys. I hope this video helped. And if you've got any doubts, please let me know. And I'd like to hear some feedback and comments down below, because negative coefficient of friction is always an interesting case to talk about. It's quite recently talked about area in mechanics and quantum physics. So yeah, have a good day, guys, and ciao ciao.